organize it a little bit more. But how does the periodic table organize metals, metalloids, and nonmetals? So if I asked you, if I gave you a clean periodic table like this and was like, highlight all of the nonmetals, could you do it? Right, that's the kind of stuff you're gonna have to do on your quiz. All right, so I'm gonna show you a way that I have found that most students are successful in being able to do this, okay? And so the periodic table, you've got your metals, nonmetals, and metalloids. And I think it's actually easiest if you find your metalloids first, okay? So on the periodic table that I have given you and we'll use from, there is this red staircase, okay? And so I'm gonna undo that highlight, but just so that you know where I'm talking from. But everything the staircase touches is what we're going to consider metalloids, except for aluminum, which is considered a true metal. So I like to start at boron in this kind of corner of the periodic table. And if you just go down, we're going to say all of those are metalloids. Now, oganesson 118 isn't technically classified, but we're just going to make it easy. And then you would start at aluminum, but we're going to skip aluminum because that's a true metal. And then we're going to go down in those two areas. So then if you were to highlight these elements, you've got boron, silicon, germanium, arsenic, antimony, tellurium, polonium, astatine, and you've got tennessine and oganesson, which those two technically, like I wouldn't, if you left them off or included them, I wouldn't dock you either way. They're not probably metalloids, but I just want you to know the pattern. And so I'm fine if you highlight all of those. Then it's easiest after you were to highlight your metalloids. Okay, so let me just label this metalloids. If you then were to find your nonmetals, okay? And nonmetals are in the upper right-hand corner and they are above your metalloids. So all of these elements over here are your nonmetals, and you'll see me abbreviate them as nonmetals, NM. And then it's nonmetals, it's all of these plus hydrogen. So you have to remember to do plus hydrogen. Hydrogen sits on the left, but it is not a metal, okay? It is a nonmetals classification. And then everything, what's nice if you do it this way, then everything that's left is a metal. So then everything else, so aluminum, and then you go over here. So everything else the sun touches, literally most of the elements on the periodic table are metals. But usually students, if you start with metals, you highlight incorrectly. And so that's where I recommend you do your metalloids first, then above it are your nonmetals, plus hydrogen, everything else, metal. Highlight that is a skill. The other thing I have on this slide is how does the periodic table show states of matter, okay? So on this periodic table, so states of matter, and I did ask you this in element sampling activity, was to find at room temperature a solid, a liquid, and a gas. Finding a solid is really easy. The liquid and the gases are a little bit hard, but you will get a color-coded periodic table on every test. And so I want you to see that the periodic table kind of does the work for you. So if you look at these elements that are in black lettering, okay, which is most elements, even if we go over here to like phosphorus, sulfur, selenium, here, and let me not use yellow highlight here. Maybe I'll go back over them. So, okay, I got rid of some of them. So like most elements with the black lettering, even if you're in the nonmetals, okay, or in your metalloids, like most elements are solids at room temperature, okay? So if it's, I don't want black. If it's in black lettering, it is a solid at room temperature. And you'll see me abbreviate room temperature as RT. You've got a couple elements that stick out that have blue lettering, and there's just 2 of them. So you learned about, most students know mercury is a liquid, and then bromine is the other one. So blue lettering is a liquid at room temperature. Then if you have red, okay, like hydrogen, helium, nitrogen, oxygen, fluorine, neon, all your gases are sitting over here. So you've got the row, column 18, which is your noble gases, which we'll talk about here. And so then you've got the red are gases at room temperature. So that's another layering. Now, on this periodic table, you can't really see it. Let me see if I can pull up one that does show what I want to show you guys here. But after uranium, okay, so on my periodic table in my classroom, which is on the wall, and I don't have a good angle of it right now, but there are a bunch of elements that are man-made, and they are usually outlined in white, but the way you guys are going to tell them, okay, so on this periodic table, you notice the atomic mass for like calcium or potassium, or most of these elements, they have like a decimal. And then do you notice that like technetium right here, or the elements at the bottom down here, their average atomic mass is in parentheses, and it has a, it just has a whole number. Okay, those elements are man-made and radioactive. So we don't necessarily know their state of matter at room temperature. And like now technetium is, it's the lightest one, but it doesn't have any stable isotopes found on Earth, okay? And so that is what you need to know with that one. And I want to see if I can pull up another periodic table that has the marks a little bit better. Let's see here. So you can see a difference. Nope, that one still has. Okay, this one kind of shows what I'm trying to show you guys. So if you notice on, you see how they're kind of like boxed out differently? You guys see that? Yes, okay. Like technetium has a box, and then like most of your elements besides uranium and polonium, but like in these series down here, and then some of them, those are all your radioactive, even francium and radium. Those are elements that they're man-made, meaning they've been made in a lab, but they haven't been synthesized. Like they don't exist on Earth without being made in a lab. Like you wouldn't just find it in the Earth's ore anywhere. So those are ways the periodic table is organized, and you can kind of view it, that I want you to be aware of. So that's one organizational scheme, okay? Okay, another one. Oh, I know what I was. So let's talk about the characteristics of metals that you should know. Now, I wanted you guys to synthesize what you found out from sampling them, but these are the general characteristics of metals, and probably a couple that you got, but then some of them that you didn't. So, and some vocab for you. All right, so metals by definition are malleable, Does anybody know what that vocab word is?
Does it mean like bendable?
Yep, it does. And the strict definition, so you can think of malleable if you think of the word moldable, bendable, those are all good ones. The strict definition of malleability is the ability to be hammered into sheets. So that's a characteristic of metals. Like, so if you hammer it, it will go into a flat sheet. So it is moldable, it is bendable, and it can be made into a flat sheet. And then the other word that gets used to describe metals is that most metals are ductile. Not all, but a lot of them are ductile. Does anybody know that word? Ductility, okay, so if I write like it out like this, so for something to be ductile or to have ductility in it is the ability to be drawn into wires. So if you think of copper wire or aluminum wire, or if you think of a gold necklace, like it's in a chain form, even like silver, copper, zinc, like a lot of metals are ductile, and so they can be pulled into thin strips and be woven into wires. So they have super flexibility, okay? Now, if you were reading about the elements, you know that some metals are not very malleable and very ductile, okay? Most metals are pretty moldable, cuttable even, like if your alkali metals, your lithium, potassium, rubidium, stuff like that. But those, like, some metals are not very ductile, meaning they would not be drawn into wires. Some metals are both malleable and ductile, but these are common characteristics of metals, meaning they apply to most of the metals, but not all of the metals. But in general, a key characteristic of metals is that they're bendable and flexible, okay? That they don't crumble, to sort of kind of say what they are and what they are not. They also are shiny, okay? And so when, okay, I missed a word there. So we've talked about like light and what color something is, okay? But we haven't talked a lot about how electrons get held by atoms. And so the reason that you get the luster and the shine from metals is that they actually hold their electrons pretty loosely, okay? So when energy strikes the surface of a metal, those electrons are able to move more freely. And when electrons move from the ground state to the excited state and then fall back down to their ground state, we know they emit light. If they can do that more easily with less energy input, then they are going to reflect the light. So next time you see something that, like, you see a shiny, clean car, or like real, like, you know, something like reflects really and blinds you, you need to be like, oh, those electrons are not held very tightly. That's what I want you to think of, okay? And that's a property of metals, that they're shiny because the electrons move when the light strikes them. Lots of students wrote down great conductors of heat and electricity. And they're all solids at room temperature except mercury. And then what do I have here? They have a relatively high density. So if you were to compare, this is comparatively, okay? Everything is a comparison. That means they have a large mass per volume for space. Okay, so density is something we will cover later in the semester in more depth, and we'll solve for it. But right now, when you think of density, I want you to think of if you had a brick that was like the size of a, you know, like a standard brick, and it was actually made of what brick is made out of. Okay, it would have a lot of particles packed into a really small space. Okay, and there would be even more than that. But if you had a piece of styrofoam that was the same size as the brick, if you were to like zoom in on the particles, you wouldn't have a lot of them relative to how much space they take up. because like a piece of styrofoam is relatively light. If you had the same size piece, styrofoam and brick, you would feel the difference. And even though they're taking up the same amount of space, how much is packed in there would be much larger for a metal. Okay, so metals generally, their particles pack in really close together, and that's what makes them so dense and heavy in even a small quantity. So high density, and again, it's relative, but compared to the other elements on the periodic table. For metalloids, and I kind of talked about this a little bit, but some characteristics of metalloids. So these are a few elements that are located along a staircase line on the periodic table. But as I was kind of getting at, there's some debate on which elements should be considered. And I mean, so I'm going to give you the list of what we'll go with, but I just pulled these 4 images off Google to show you that every single image on Google gives you a different list of elements. So you can see in this one, it includes most of the stair step, but it ignores polonium, tennessine, and oganesson. And then this one doesn't include astatine, but it does include polonium. Then you've got this one, which matches ours, but this periodic table doesn't have the last row. And then you have this one down here, which doesn't include polonium, astatine, or the other ones. So you see how like there's some debate? Different places will tell you different ones. We're going to keep it simple, and we're going to go with boron, silicon, germanium, arsenic, antimony, tellurium, polonium, astatine. You can include tennessine and oganesson if you want. They are new elements. They don't even show up on a lot of periodic tables because they just got named a couple years ago. And you'll notice on some images sometimes that I'll have, and you'll see on your homework that sometimes this last row on the periodic table is not filled in, or it has different names for stuff, because it's only been in the last year or two that we have named that final row elements there. But those are the metalloids we're going to go with. So their characteristics, though, they're usually more brittle, okay? And the word brittle means that they're flaky, like not like your friend is a flake and didn't show up, but like that they will flake off if you try to bend it or break it. They're more likely to crumble. So like a metal is stretchy and bendable and moldable like clay, you can think of. Metalloids somewhat, but they tend to be more brittle. So they will kind of flake off. And so silicon is a really good example of a metalloid here. Show it. Just stop the share for just a second. So even, oh, it's crumbling in my hand, flaking off. So here it is very shiny, silicon. It's very pretty, but it's very light. But it has the luster like a metal. So it definitely like looks like a metal, but it had like when it chips off, it can have these little breaks, and it's not like I can't mold this. Like it's hard, and let me put some of these pieces back. Maybe you can see the dust on my hands a little bit there. So it flaked off even if I was holding it, but I can probably break this piece. Let's see, maybe not. I'll have to go get my hammer for this one. Hold on, let me get a thinner one. Yeah, but it does flake off. You can see that dust on my hands. So, and now it's on my computer. It's fine. It's fine. Let's see if I can break this one. Oh, okay. I got like a little piece off, and it just kind of like flaked off of the piece I was holding. Okay, so that's what I mean when it's brittle. Like it can just kind of flake off. If I were to chip at it, it's not very bent. It's not bendy. Like I'm not bending this. It's just gonna break if I try and bend it. Okay, so that's something with most of the metalloids there. Then you have they are shiny, but they're not usually. Silicon is probably the shiniest metalloid. The rest of them are kind of like in the middle. But they're not dull either. And not like dull like your friend is boring, like dull as in they're not that shiny, okay? And that's because they hold their electrons kind of halfway, like they hold them tighter than metals, but not as tight as nonmetals. They are semiconductors, which is actually some like really good for like electronics. You don't want stuff to conduct too much electricity too fast. And so that's where you've heard of like Silicon Valley maybe, and then a lot of your electronics use the metalloids in them for all the stuff that we're doing right now. They are all solids at room temperature, so that's a characteristics. It's the only group that you can say they're all one state of matter, because all metals are solid except for mercury. And their density is kind of all over the place. They have a range. I don't have that on the slide, but they don't have a lot of similarities, like each one is different, but these are probably the things that I was hoping you would pull out and know. The nonmetals, I did not grab my sulfur. Okay, characteristics of nonmetals. So nonmetals are very brittle. They do not bend. They will only break and flake off. So now some allotropes of nonmetals, but so this is carbon coal. I'm not going to open this because then I'll be all dusty. But like if you've ever been a coal plant, and some of you guys are writing with a pencil, so you're writing with carbon graphite, which is an allotrope of carbon. And I don't need to make this like super big because hopefully you've seen like little hunks of coal, or seen like, oh, you're going to get a hunk of coal in your thing for the holidays because you've been bad this year from Santa. But carbon is probably the most versatile nonmetal. It has different forms and whatnot. But if you are writing with carbon right now, which if you are writing with a pencil, you can see how smooth and how it's just flaking right off. Okay, that's brittle. All right, and if you take an actual piece of pencil lead, you can't really bend it; it will break. Nonmetals are dull. I mean, ain't nobody writing with some sparkly pencil. All right, you can write with a sparkly pen, but it's got to have different characteristics than the non-metal carbon if you're writing with a pencil. And that is because electrons, when they hit the surface, they do not move as much. And so we see light and we see reflection when electrons move. So that's what's happening. So the next time somebody's like, oh man, that object is so dull, it's not bright at all, you can be like, well, those electrons actually are just held tighter, and so the light isn't really reflecting off of it. I know that's totally what you're going to say to your friends. They are poor conductors of heat and electricity. So, and that is actually because those electrons don't move. Okay, so reason stuff conduct is because electrons move. So the electrons, this all comes back to the electrons are held tightly. Okay, and so they don't kind of react. The atoms are kind of greedy, and that makes them very poor conductors of heat, because what conducts heat is electrons moving. FYI, well, that's one form. They do tend to be liquids or gases. At room temperature, comparatively, they have low melting points. There are some there are some solids, but they tend to have low melting points, but they're mostly all liquids and gases. They have low density, so they take up, well, if given the same amount of space, there will be far fewer particles because they will have much less particles in the same amount of space. That's the easiest way to understand density, is it's how many particles there are in a certain amount of space. So if you give a metal and a non-metal the same amount of space to pack themselves in there, a metal is going to fill up every little corner, and a non-metal is going to be somebody who's like really bad at a packing job and like has a lot of empty space in their vehicle, and they're like a super packer would be able to fit like twice as much in there. We all know, like my dad is a super packer. He can fit any space with like stuff in every nook and cranny, right? He's like a hoarder. I mean, I'm just going to say it. And then you've got like my mom, who is like challenged with like three-dimensional space. And so when she tries to fill up a space, there's like, Mom, there's like half the room is empty. So think of my dad like a metal and my mom, who's not a good packer, like a non-metal. And then you understand the difference. Okay. All right, so some other vocab that you're going to learn about, but I want to highlight is what is a period on the periodic table. And so we have talked about this. So they are the horizontal rows on the periodic table, but we're going to think of them as the energy levels, okay? And the periodic table is organized this way. So it's very intentional why there are 7 rows, okay? And it's called a period, all right? So if you don't have the side, usually most periodic tables, the sides of them are not labeled, but you would just go down here and label 1 through 7. And those refer to the energy levels, the rings around the nucleus where electrons can go. All right, so and whatever energy level, whatever period you think of them as rows, horizontal rows, but that tells you how many energy levels the electrons sit on in that atom. So if you have an element in period 3, that means that it will have electrons on the 1st, 2nd, and 3rd ring. So the reason like potassium is in the 4th ring right here and not in the 3rd is because it has at least an electron in the 4th energy level. The elements, down here in the 5th, 6th, and 7th, and then we have seen that so it goes 55, 56, 57 through 70 are down here, and that's just to make the periodic table not so wide. You did see on the photographic periodic table here when you clicked into an element. So if I clicked into hydrogen, in theory, it's going to show this. So the long periodic table, so if you're looking at yours, all right, that's fine, it's not going to work. But if you look at, you've got cesium and then barium, and then it does lanthanum. So it puts that series down there, and it makes it really wide, right? So most periodic tables that fit on one page move these boxes down here so that it's not quite as long. But we could cut and paste this and make it super wide like you just saw on this. So this one did put those 2 14 across rows down there. Do you see the difference? Okay. It's like someone snipped this area and then was like, let's just move it down to make it easier. I don't know if it is, but that's just common. But this period, okay, it goes from here and then down here, and then it comes back. So all those elements are in period 6. And then all of these elements are in period 7. So there's only 7 periods, energy levels where electrons can go. So then if that was our nucleus, right, and we were going to do our rings, there's 1, 2, 3, I have to go back up, 4, 5, 6, 7. Those are where electrons can go around the nucleus of the atom, okay, if you're just trying to visualize it. And that's why it's one of the reasons why it repeats. And then, let's see. So are you sure you notice that there's a lot of organizational schemes already that for that how stuff is kind of placed and where it's located, like that there is reason for it. That's what I'm hoping you're getting out of this. And then the last one I want to cover for today, which you will learn about this this weekend, but hopefully it's stuff you can just be like, okay, yes, and see how they word it. And it might be worded a little differently, but it'll just be like a refresh. So what is a group or a family on the periodic table? So when you think of like a group, like, okay, an organization or a family unit, whatever that family unit is, you tend to think of things like a running group. Okay, it's people who like to run. The soccer team, it's people who like to play soccer. My mom's in a quilting group, you know, whatever, because she likes to quilt with other people. Like my family unit, my mom, my dad, my brother, like we're a family by blood and we have similar characteristics. We're not the same, but we're related or we have something in common. So a group or family is a vertical column, that's the word I was looking for, and on the periodic table. So it's a vertical column on the periodic table. And it's called a group or a family. What else was I gonna say? Oh, okay. They share traits. So there are some that have names, but if we just kind of, there's two different numbering systems and you will see both, and I don't want you to be confused by them. So on this one, you can see there's numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That is common. There's 18 groups on the periodic table. It's 18 wide, all right? Now, that's the new system and some people will still refer to the A and B system. So the other way to number the groups that you may see is this is 1A, this is 2A, okay? Then I'm gonna 1, 2, skip a few, I'm gonna skip this region, and then we're gonna do, this is 3A, 4A, 5A, 6A, 7A, 8A. It's like I'm from Minnesota or something. A. I actually am, but it's A, you get it. Okay, all right. Now this section right here that I skipped, so the A's, okay, versus the B's. Yeah. So then this, so you've got the 3A, 4A, this would be 3B, 4B, 5B, 6B. You can add B's after this. So if you see the A's and B's, then you can know that that is the old naming system. Now, A's and B's got confusing for people, which is why they just switched 1 through 18. But it is nice actually, the old system at different times. So I want you to be familiar with both. So there are some groups on the periodic table that have common names that you're going to learn about. So the group 1 or 1A, not including hydrogen, because hydrogen is not a metal. Those are your alkali metals. And then group 2A, all of them, those are your alkaline earth metals. And I promise you will, if you only got one clean periodic table out today, it's probably a hot mess, isn't it? I should have probably said 2. Normally in class I say, get out, I was like, switch of periodic tables. The area in here, this region, groups 3B through 12, or 3 through 12, or 3B through 12B, they all get lumped into your transition metals. They don't get individual names, but they are your transition metals. And then this area right here, 3A through 6A, or like groups 13 through 16, just get called by what the top element is. So this is like the boron family, the carbon family, the nitrogen family, the oxygen family. They get named by the head of the family. And all of these elements, like boron down, they share more in common than any other group on the periodic table. So that's when I say whether they're called like a group or a family, like that area of the periodic table, they have more in common than other groups. And then group 17, or what? Doesn't want to give me the color that I want. Rude. Okay, fine. Just do red. Group 17 or 7A are your halogens. They do get a special name. And then the final group, I guess I'll do in fun pink over here, or yellow again. Ah, there we go. Those are your noble gases. We'll learn more about each of these, and you'll learn more about each of these, but that's the organizational structure. I was trying to do the rainbow, but it wouldn't let me do orange. I kind of got messed up. And then down here, I didn't forget about the lanthanide and the actinide series. It really doesn't want to give me a different color. So these ones are your lanthanide and actinide series. You can see they're labeled, but they're also known as the inner, whoa, that's not what I wanted, inner transition metals. So you've got your main transition metals and your inner transition metals, and then you'll also learn that the, so groups 1, 2, 13 through 18 are what's known as your main group elements. Or the representative elements, that's 1, 2, 13 through 18. And then you've got your non-representative elements or whatever, they're your transition metals. So that's a lot. I think that's plenty for today. And you will go over this in the reading and whatnot, and you'll learn more specifics about the different groups and organizational patterns. And there's a couple more, but we'll save them for after.